All right. So the Python language is actually developed back in the early 90s by this guy. You can tell just by looking at him, he's one of us. He's a geek, right? Just like us. And he was basically at the time working as a server admin. And when you run server tasks and you do them on a lot, and usually you're working from a command line on a server very often, especially back then. There's tasks that you do, like, for example, let's say like his job was to take a list of users and create accounts for them, right? And come up with passwords and settings and stuff. And that's a repetitive process, but that process might involve like running one command saying create user, and then running another command add password, doing another command create home account or home directory or something like that. It's a series of steps. And you know what? When you have a series of steps, you can actually write computer code to automate those server tasks. So you don't have to like wait till one task is done. You could write in principle one set of code and then run it over a whole list of users and just basically run one command and you're all done, right? Clever, right? That's called scripting when you're working on the server. So it's kind of like programming, but it's really more giving like a series of commands. We used to call it a batch file, right? Like a batch of commands, and we'd run it. He developed Python to basically help him automate those tasks. And I think it was largely because he didn't like the other scripting languages that were out there, like bash scripting, for example. It's kind of painful. We used to write batch commands for Windows too, but that was why he did it. Eventually, it kind of evolved, and he kept adding new capabilities to it. And once again, keep in mind, it's not a compiled language. Does not create an executable. It's a series of commands. And when you think about the fact that he was automating commands for a server, it totally makes sense, right? It has now grown to the point where it runs on every platform, that people use it for much more intensive tasks than simply automating tasks. Totally. Now, we did go through these screens here where we did the install. If you guys remember, they have a guide here. It is a little bit dated, but it is what it is. All right. So we are going to get into coding here in just a moment. We're going to kind of talk about it from a high level first. The first thing that we're going to talk about is some of the features of the book, which is kind of neat. So if you guys notice, I'm using the ebook version. This is why I like the ebook a lot. And it has a example little program. By the way, all the sample code that's in all the chapters is available in a zip file in the course resources folder. So anything that you see in chapter, you have that code available to you, right? You can also get it from the publisher if you have the scratch code from the book, if you have a hard copy, or if you bought the book with an access code. But I have it all in the course resources, so you don't have to go hunting. But this is kind of neat because let's take a look at this program here, and I'm going to bump up the size just a tad so you can see it a little bit better. Kind of messes up the line numbers here, but hey, whatever. All right. So the first thing that we notice in this program is we have a comment here. You notice the pound sign, right? And so that means that what follows that pound sign on that line will not execute. That's just information for you, the programmer. People seeing the program running don't see this. Only the programmers see this. So you can put these comments in your program all over the place to leave notes for yourself or to explain what's going on. Now, when I'm coding in class, you guys will notice a lot that I do it to remind myself what I'm doing. Sometimes, like if you were in a database class, sometimes the instructions are really long and complicated, and I don't want to keep flipping back and forth. So I just copy the instructions into the program in the form of a comment, and I have it right there to look at. Right. The other reason I use them often is if I try something and it failed, then I can have it right there to look at and go, don't do that. It already failed. Just see every iteration of what I've tried until I get it right. Now, once I get it right, I can get rid of that, but that's another usage. The first command that we're going to play with, and this is the only command we're playing with tonight, by the way, is the print command and how it works. And print technically is what we call a built-in function. It's something that we can trigger in the language. There's programming code that's already written that takes what you put in between those parentheses and puts it on the screen of the user. In this case, whenever I have double quotes in there, anything in between those double quotes, and by the way, it could be single quotes too, either one work, that will end up on the screen verbatim, just like you see it. So hello world with a comma and a space and an exclamation with 2 capital letters will appear exactly like that on the screen. The ebook is kind of cool. I can actually run that code and it will output inside the book. That's pretty slick, folks, right? And in some cases, you can even manipulate it. The whole reason this works inside the ebook is because Python is not compiled, it's interpreted. So it's just another set of instructions that changes the code on the screen. It probably converts to JavaScript or something. I don't even really know if they're really driving it with a Python backend. They might be, but there you go. So whenever you see code snippets like this in the book, you can sometimes change those snippets and try them. In this case, you're just trying to see it, right? So that's kind of neat. All right, so we talked about a comment. That's with the pound sign in front. We'll learn a couple more ways. We learned the print function and how that puts stuff up on the screen. The stuff that goes inside the parentheses of a function, we either call that either an argument or a parameter, depending on what perspective we're coming from. And that's pretty normal. So in other words, that's information. The stuff inside the parentheses is information we're sending to the function for it to process. All right. All right. All right. So a couple little interesting things here is as we start to play with the syntax here, you will discover that you can intermingle text with math using commas. That's one way to do it, by the way. There's other ways. For those of you that are used to standard concatenation techniques, that also works, but you have to be careful with those plus signs because Python actually handles concatenation in a number of different ways. We'll start with this methodology here, but I'll show you others as we go, right? I like to stick with what the book does generally because I think it makes more sense for you. Another thing you'll notice with the print statement is that, and we learned this in the Kahoot, right? If you just put numbers in there, like, for example, if I say print 3, it'll print the number 3. But if I say print 3 plus 4, it'll do the math first and then print the answer. If I wanted to do math and text, that's why I would use this approach. I would say the answer is inside double quotes, a comma, which is the joining character, and then the math. So the answer is 6 times 7, which is what? Right. Okay. You guys should do math for that. What's kind of different between the concatenation techniques of this language and others, if you guys know other languages, is this comma also helps to add in the space that you normally would be forced to add in other languages that you don't think about. So this is why the author shows this technique, but you can use the other concatenation technique as well. All right, so we're going to play with some of these. And here's another little example. We'll just go ahead and run this, but we're going to play with it ourselves. So here's comments, right? Here's a print statement, tells you what it prints, right? Print hello, print world. Those will print on 2 separate lines. It's kind of the takeaway there. And then here's one where we're intermingling text and math and text and math. And then here's one where we print goodbye, print a blank line, and print hope to see you again. And here's the output, right? So if you can get that all on the screen at the same time, you can see which commands generated what. All right, we'll play with this in just a moment in the actual IDE. Let's move on to the next comment here. There's like little sample exercises in there too. I don't usually do those in class ever. But when you guys are working on your own, it's not a bad idea to try those. You know, why not? You paid for the book, especially the ebook. And I do find that, like, especially if you're new to something, it's not a bad place to goof with stuff until you try it for real. All right. So here's some examples of errors that might happen as we're coding, by the way. So the print statement, normally, if we're putting text on the screen, we want to put all the text inside of double quotes. And you notice that the closing double quote is here. So when I would go to run it, the 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 error checking engine or the debugger inside of Python will give you an error on the screen, and it will say the file name, what line it appears on, and then it'll put a little display of the code and a little pointer showing where it thinks the error is. And it's not always right, but it's usually kind of close. Usually, wherever that pointer goes, I look in front of it to find the error. That's kind of a standard rule of thumb. Notice the actual error is a syntax error, meaning you didn't type the code in correctly because you're missing the double quote. And it says end of line, that's what that stands for, EOL, while scanning string literal. Means nothing to you now, but it will soon. Basically, we're literally adding a string of text and we didn't do it correctly. That's what it's telling us, right? And so you have to learn how to read some of these errors. Now, here's another one where no double quotes are in there. Now, it does, if I put numbers in there, it knows what to do with it. But if I have text without double quotes, problem, by the way. We'll see that in a second also. Here's an example of some math. Okay, well, we learned that we can take math, put it inside the print statement without double quotes, and it should do it. What's the problem with this math? Yeah, you can't divide by 0 in base 10 mathematics. It doesn't work. So it's not that it can't do math, it can't do the dumb math that we put in there, is what it's telling you. Divide by 0 error is not allowed, by the way. So this type of error, right? So, okay, just to kind of notice, this is a compile time error, so we don't see this error until we run it. Here's what the reality is. When we're typing the code in a good IDE like Spider, Spider will point out the error in the code window before we even run it. So we will never hit that error. You guys feel what I'm saying? Right. So if it's syntactically incorrect, you will see it highlight. Why this is pertinent is if you were a coder that was creating a plain old text file and then going to the command line to run and compile it and all that stuff, then you would see the error. Because if you're using a plain text editor, it does not have a debugger built in. That's why we use an IDE or integrated development environment, because it on the fly shows us our mistakes, right? And this is an important thing too. Compile time error and an exception error. This exception, which is the divide by 0, this is called a runtime error. So it wouldn't flag this as wrong necessarily in the coding engine, but it would not work when you tried to run it because you can't divide by 0. We also have the whole concept of a logic error, but a logic error is a lot harder to show because it just means that your algorithm or your steps in your program are not in the right order. They're not the right thing to do. It's not the right math, whatever. The logic that you're coming up with is wrong. Simple as that. All right. The other thing that the chapter does, and they do this at the end of the chapter, and you notice I started the whole class with this, is there is a whole background to doing this problem solving and algorithm design before you start to code. And this is a really hard thing to teach. And once again, when we're doing the simple programs like we're going to do tonight, you probably won't need to pseudocode. But by the time we get to chapters like 8 or 9 or 10, when the stuff is a lot more complex, you're going to have to start thinking about, okay, well, what do I do first? What do I do second? I guess I need to sketch this out a little bit before I roll with it. Then you're doing algorithm design. And so they kind of do an example, like if you put $10,000 into a bank account that gets 5% interest a year, how many years does it take for the account balance to be double the original, right? So you can look at the little chart here. So like what a programmer would do is like, well, I don't know. Like I could like make a little chart. I could even do this in Excel with formulas and stuff and lay it out. And you keep going. Well, obviously 4 years doesn't do it. How many years does it actually take? Right. And so that's the kind of thing that you would design. But how do you figure that out? Well, every year you take the money, you figure out what the, like if you have 5% interest, how much you're earning, then you add that back to the original amount. Then the next year you're adding interest to that amount, right? And this is one of those classic things. And how long before this person has $1 million? Here's another question, right? If only we could put our money in the bank and not touch it, right? And get a good rate of interest, right? That would be an excellent rate of interest for a savings account, but that's not how much you get, right? It's like 1% or something silly, one and a half, maybe if you're lucky. But the whole point is there's an algorithm. And here in this case, they're actually using a loop. We haven't learned about that yet because the process is repetitive. And you figure out the process, you think of the logic, and then you write the code. It's so much more helpful if you can visualize it somehow, like what it's supposed to do before you write the code that goes with it. Simple as that, right? So that's why we do it. It makes the code correct. And then notice they even do a little flow chart here. But this flow chart is about the process of programming. So look at the concept here. And I want you really to latch onto this, right? You can't write any coding problem without first understanding what the problem is. So I know some of you will have some of our other instructors, but I'll say this to the software developer folks in the room. Like if you've ever taken a class with Alan Pearson, right? Like, and Alan's like totally on point with this stuff. We were at a meeting like not more than a few weeks ago, and we were tasked to perform a certain thing, right? And then he asked the question, he goes, why are we doing this? tell me why, and then I'll come up with the right solution, right? So you got to understand why you're doing this. Once you have that, then you can develop and describe an algorithm like your recipe. And then, of course, if you have a recipe, you would test it, right? And then you would translate that into like actually doing it, and then you run the program. But this process is pretty normal in programming, right? And most of it, I want you to notice, is not necessarily about coding. That's even the other part that people kind of forget. Yeah, we do write a lot of code. We spend a lot of time writing it, but you also spend a lot of time thinking about how to make it work before you actually do it. And anything that's complex is like that. Understand it, come up with a way to do it, try doing it, make sure that it works, and then you're good to go. Right. So that's kind of the general lay of the land. All right. So I'm going to end this recording here. So that's kind of like the end of the chapter 1.